Welcome to qnawire.
For the given problem, we have following situation. Two containers are connected by a cord and they are passed through a pulley, a frictionless pulley. In part A, we place the origin of the coordinate system of the center of the pulley with x-axis horizontal to the right and y-axis. So we place here x-axis horizontal to the right, positive, and this is the y-axis up. Rather downward here. So let's cancel out this one here. So y-axis here. This is our x-axis. The center of the mass is halfway between the containers at x is equal to 0 and y is equal to L, where L is the vertical distance from the pulley center to the either of the containers. So from here to L is here or here. Since the diameter of the pulley is 50 millimeter, the center of the mass is horizontal distance of 25 millimeter from each container. Part B, suppose 20 gram is transferred from container on the left to the container on the right. The container on the left has a mass M1, which is 480 grams, and is at x1 at minus 25 millimeter. The container on the right has then mass 2, which is a 520 gram at an x2 plus 25 millimeter. The coordinate of the center of the mass is then, we can write x center of mass to be m1 x1 plus m2 x2 divided by mass 1 plus mass 2. Substituting values 480 grams times a minus 25 millimeter plus 520 grams times a plus 25 millimeter divided by 480 grams plus 500 grams. This gives us a center of mass to be 1.0 millimeter. The y coordinate is still L. The center of mass is 26 millimeter from the lighter container along the line that joins the bodies. Part C, when they are released, the heavier container moves downward. So the heavier container moves downward and the lighter container moves upward here along the line that joins the so the heavier will come down and the lighter will go up. So the center of mass, which must remain closer to the heavier container, moves downward. Center of mass moves downward. Part C, because the containers are connected by the string which runs over the pulley, their acceleration have the same magnitude but in opposite direction. If A is the acceleration of mass 2 and minus A is the acceleration of mass 1, then the acceleration of center of mass will be m1 times minus A plus m2 times of A divided by m1 plus m2, which is A times, so A times this will be A times mass 2 minus mass 1 divided by mass 1 plus mass 2. Then using a tension, we can write we can find acceleration to be using a second Newton law, that is m1g minus t is equal to minus m1a, and t is equal to m1g plus m1a, and m2g minus m1g minus m1a is equal to m2a, where a is equal to m2 minus m1 times g divided by m1 plus m2. So the center of mass of acceleration will be g times m2 minus m1 square divided by m1 plus m2 whole square. Substituting values, 9.8, here we have 520 minus 480 square, 520 plus 480 square. This gives us an acceleration of the center of mass to be 1.6 times 10 to the power minus 2 meter per second squared, which is downward.